So we just talked about Euclid, the father of modern geometry, or this is called Euclidean geometry. There were three things that he had to basically assume. And they were the only three things that he allowed himself to assume. And they were the first three things we're going to look at here today. What a plane was, what a line was, and what a point was. Those were the only three things he could assume. Everything else he proved. He showed with sentences, paragraphs, whatever, that it was true. Okay, so you got to think, there's a lot of things that you kind of take for granted. Oh, that's just the way it is. Somebody along the way had to prove that that was true. All right? And Euclid did a lot of that for geometry. Now, you might notice that the plane right there is P-L-A-N-E, not P-L-A-I-N. All right? Slight difference there. And this plane here, obviously not talking about an airplane. Okay. This plane is what we're going to use a lot of, and it's sometimes a very difficult concept for students to understand. But a plane, and you can always paraphrase definitions, because I never along the way am really going to ask you to give those. But a plane is, and as you can see, the smartboard's working perfectly today. A flat surface. Again, read it once and then start writing. Don't just start writing. You got to write down what's going to make sense to you. So it's a flat surface that extends indefinitely in all directions, has no thickness, and it will be labeled with an uppercase letter. Okay. Now it's very hard, obviously, then to draw something like that. So a lot of times when we draw a plane, we kind of draw something like this. Now, does that go on indefinitely? No, that stops. Indefinitely means that it just keeps on going. But we draw like that, and then we'll put an uppercase letter. Normally they'll put it down here, so something like that, N. All right. And then on that plane, you can have a bunch of points all over the place. But basically what they're saying is that has no thickness. So in other words, it does not go back into the smartboard or come out at you. Okay, it is so thin that you can't even measure the thickness, is basically what they're saying. So some people kind of think of like a sheet of paper if it were to go on in all directions, up, down, if you had a sheet of paper. A lot of people use that, or even this whiteboard. Some people kind of think of that as a plane, but kind of just this surface here, not the thickness, because obviously you can see the smartboard has thickness. But we're talking very, very thin. It goes on in all directions. Okay. Again, normally notated by something like that, because how do you draw something otherwise? You can't. Right? A line. Would anybody like to try that one? Yes. Not bad. Pretty close. Okay. Believe it or not, a line is actually a tool to connect points. Again, no thickness or width. Does it look like they do? Yes, but no, we're going to say that there is none there. And as we were told there, they go on forever. So pretty close on the definition that you gave. Key, there's no thickness. And lines will also be normally named with a lowercase letter if that's all that's on there. So for example, like this, maybe here they'll do an N like that. See how that's lowercase? You can name a line that way. So plain will have the uppercase. It doesn't have to be N. I just chose the same letter. It could be any letter of any alphabet, not necessarily ours. And then the line is N on this next one. And a point. Simply a dot. I think we all know that. But again, there's no thickness there. There's no width. And it's labeled with normally an uppercase letter. Okay. So for example, I could put a dot right there, and maybe that's point A. Okay, right there. Just kind of like we did yesterday, right? We put dots on there, we put an uppercase letter on it, right? We never put a lowercase, did we? Yesterday, it was always uppercase. And sometimes points could be here. Maybe it's on that plane. Maybe that point is on this line. All right. Points can be pretty much anywhere. Points can go in three-dimensional space, which is another one down there. Okay, so, excuse me. Those were the three things that Euclid limited himself to. He said, I'll assume those. The rest of these, I'll go and prove them. Okay, I'll show that it is true. I think most of you probably know this next one. A line segment is simply a section of a line basically it has to have endpoints. It has a place where it starts, a place where it ends. So in other words, it does not go on forever. Right? And notice it says end point, or end points, I probably should say. A, perhaps, to B. And is that acceptable notation? Both of my dots are uppercase. Is that how they're supposed to be? Both of my points are uppercase? Yeah. Or capital? Okay. Space. Yes, it is the final frontier, but not what we're going to use here. Not sure many of you would come up with this one. It's very short, but it's somewhat complex. A boundless, three-dimensional set of all points. So it's not saying outer space, right? It's just saying space. Boundless, meaning goes on forever. It is three-dimensional. Up, down, back, forward, whichever way you want to go, diagonal maybe. And it's all points. I can't even really tell you this room, all this room everywhere could be considered space because this is boundless. It has walls. Okay, space is just everywhere. Okay. So these are key. And most chapters will start this way. We'll have to do some definitions, and then what we're going to do next is name things. Because when I say stuff up here, you got to know what I'm talking about. Right? And so we'll go to naming things next. Are there any questions on these definitions here? Okay, and keep in mind, I'm never going to make you do it verbatim, is what it's called. I'm not going to sit there and ask you to give the definition of plane, and if you mess up one little thing, it's wrong. All right, if you give me something that's acceptable, it makes sense to me, I'll give it to you. All right. So name the following line in as many ways as possible, and there are a lot. All right. As you've probably figured out, I've said it a few times already, and we're only in, the third week of school. Mathematicians inherently kind of lazy because we always try for shorter ways or easier ways of doing things. Okay? So we work hard to work less, if that makes sense. One of the easiest ways to do this one is, you notice we have some dots here. We have some points, right? We have A, B, and C are points. Is there a dot next to that N up there? No. So is that a point? No, it is not. It actually has to have that physical dot there to be a point. And plus, that's lowercase, isn't it? That can't possibly be a point. It's lowercase. So one way you could do it is to say, line, you don't have to do cursive there, but line N. Because if I said, let's say I had a bunch of other lines on here, maybe I got another line going this way, maybe, and that one's M. If I say line N, would you know which one I'm talking about then? And that's the key. As long as I say something and you actually look at the right spot, and then, well, that's what's important. All right. And again, there's line M. We don't want that one on here anymore. Let's get rid of that one. Another pretty simple way. To name a line, you need a minimum of 2 points. You might want to write that down somewhere. A minimum of 2, you can have more, of course. So one way you could do it is, that's 2 points, right? And this is kind of where the laziness comes in. You just kind of put a little symbol over top, 2 arrows on it like that, that's a line. Line AB. Now technically, is it okay to do it in non-alphabetical order? Can you say BA? In this case, you can, sure. That's fine, right? And from now on, I think we'll stop doing the transpositions of the letters there. That just means switching their spots. We'll stop doing that. So it's not really in all ways possible, but you get the idea. Is it okay to skip points? For example, can I do that? Can I skip over B? And what you have to ask yourself is, if I said line AC, would you all look at the right place? I think you would, wouldn't you? You'd look at the one that has A and C on it, right? Because maybe I have another one, maybe M actually comes through here, right? All right, so maybe there's a D and a E. If I said line AC, I think you're all going to look at the right one, aren't you? You're not going to look at M, you're going to look at N, right? So that's okay to skip around. You can do that. And we'll just do a couple more. So we won't really do it in as many ways as possible, but B, C, that's good, right? You would all look at the right one. I think you kind of get the idea, don't you? How many ways you can name a line? There's a lot of ways, right? But let's say there was a point, maybe the D's over here. If I want to name that line there, should I use D? No, because D's not on it. That's not going to help me. So don't do that. Okay? So, find which way is going to work for you. For me, I kind of do something like the AB with the little line over the top because it's nice and quick. Doesn't take very long. But again, if I say line N, you better be able to find it. Okay? This one can get people from time to time. Naming a plane. Again, we might not do it as many ways as possible. We'll just do a few. I think that's on your next page there. For a plane. So for a line, what's the minimum for a line? Points, right? What do you think the minimum for a plane is? Is it also 2? Yeah, it's actually 3. Okay. Minimum for a plane is 3. I will explain why that is in a second. But probably once again, the easiest way to do, say, this particular one is, you see this one right here, down here, does that L have a point next to it? And normally they will, I'll try, and the book will try to kind of italicize the one that's actually either the line just general name or the plane's general name. And so that's one way you can do this one, plane L. All right, that's one way you could definitely do that. All right. And if you need a minimum, well, plane, well, you need 3 points, so give me 3 points. So D, G, F. Doesn't matter what order you give those letters in. No. Okay, this will be a hard one for those that are just listening to the recording, but for those that are here with me now, this so that you can see what I'm doing. Because right there you have a plane, correct? Is it possible I could have another plane coming through like this that would also hit D and F? See how this plane could cut through just like that? So if you told me just plane DF, would I know which plane you're talking about if I had another one that cut through like this? D and F are on both planes, aren't they? So it's not enough. But if I say DFG, then do you know for sure which one I'm talking about? Yes, you do. Or let's say I had DF, and maybe there's a W right out here where I'm pinching my fingers. If I said DFW, then do you know which plane I'm talking about? Then you do. You know I'm not talking about this one that's on the smartboard, but the one that's coming off on this sheet of paper. Okay? And so that's why you need 3. Because planes can cut in there in so many different ways, you need to make sure that you know which one's being talked about. Okay? Yes? When you're naming it, the only way you can use one is that one. To name it is a minimum of 3. You don't have to have 3 points on that plane. Those don't have to be there. If those are not there, can I name the plane in any other way but that? No, I can't. All you can say is plane L. That's the only way that you would for sure look at the right plane. Okay? Because again, I could have that sheet of paper cutting through there. Because this plane could have more points on it. This plane could have 203 points on it. Okay? But you just got to pick 3 of them and use those to name it. You need a minimum of 3. Okay, great question. Okay? But again, if those ones aren't there, you just got to go with the other way of naming it. Okay, good question. Okay. Any other ones? All right. So you can name a line, you can name a plane. What else is next? Oh, hey, these look familiar. Collinear. We talked about that yesterday. Anybody want to give it a shot today then? Yeah. Yeah, I think that pretty much sums it up, right? In fact, I think that's exactly what that says. Word for word. Points that are on the same line. Again, remember that AR just turns it into an adjective. The prefix co, that means with or same. So then there's your non-collinear again. Don't overthink it. Yeah, there you go. Points that are not on the same line. Again, word for word. What I have up there. Wait a minute. These next 2 are new. Coplanar. So what's the root of coplanar? What's the root word in there? Is really, go ahead. Plane. So the AR again just turns it into an adjective. Co kind of means. You see how easy this is if you just break down the words? It looks a little scary, doesn't it? But really, if you just break it, that's pretty simple. Okay. So coplanar. Well, let's kind of. Which one do you think it matches up with up here? Is it collinear or non-collinear? Which one does it kind of just shout it out? Kind of matches up, but that has a root of line. So this has a root of plane. You think you can figure that out then? There you go. See, this isn't rocket science here. Something, just break down the words. Are you going to get some words with lots of syllables in them in here? Yes, you are. All right, you're just going to have to break it down. And I think we all probably have a pretty good idea what the next one is then. All right, yeah. And now some people struggle with that concept, though, and that's non-coplanar. And what I'll do is I'll go back to that last example and try and help you out. Again, those just listening to the recording are going to kind of miss out on what I do that you can't see, but do you agree that D, G, and F are coplanar, right? Again, what if I take that point and all I'm doing is just pinching my fingers out here in the middle of nowhere and say that that's point W? Are D, G, F, and W all together coplanar? No. So again, just like before, how many bad apples do you need? Just one. Can you have more? Could there be points all over the place in here? Yeah. And if I go with D, G, F, and any of the points that are out here in this room, they are non-coplanar, correct? But all you need is that one. And all of a sudden, the group of four, not coplanar anymore. Okay, and again, I could just throw a bunch of them on here, right? Are those all, even the red ones I just put in, those are all coplanar. All you need is one out here that's not on that plane. It's all done. Okay? And hopefully, you can then talk about these. So let's name 3 points that are coplanar. And we'll say that the plane actually kind of has to be drawn here. So do you think, can anybody just tell me 3 points that appear that they're on the same plane? Kind of think of each side of this box as a plane. Obviously, I know they stop here, and planes are supposed to go on forever. We'll just kind of pretend they do. Yes? Are A, F, and G on the same plane? What do you think? A, F, G. Are they on the same plane? Yeah, we would kind of call that, what, the top? Right? So I agree with the A, F, and G. That's good. Okay, is that the only answer to that first question? No, there's lots, right? If you want to add in more, that's fine. I mean, what, F, G, and D? Okay. B, G, and C. You see how I jumped around there a little bit? B, G, C, that still doesn't matter. They're still on the same plane, all right? How about 3 non-coplanar points? Again, the plane's not really drawn there. This one gets a little bit harder. Yes. A, E, and what'd you say? So she said A, E, and C. I agree. A and E I would kind of consider on the back, right? We can't really see it. And C is kind of on the front. Are all 3 of those kind of on that same plane? Again, I'm saying go with the ones that are drawn. Because is it possible to draw a plane through those 3? It is possible, but we don't see that one, right? So A, E, C, that's good. And then I wrote a G for some strange reason. That was one of those where I was not just seeing if you were paying attention, I just messed up. All right? How about 2? There's a lot of answers to this one. We'll just assume that these sides do continue on, because really they're segments right now, right? Because they kind of stop. But we'll just say, let's say they just keep on going. These are the easy examples to talk about these words. That's why we do it. So could I say, according to what we have here, are A and D collinear? Is there a line right now that connects A and D? No, right? But what about A and F? Yeah, so is that okay to say that one? Yeah. So, and it just says to name two points. So it's okay just to say A and F, or, I'm not going to sit there and yell at you if you do something like that, okay? Really, it's just asking for the points here, so that's how you probably should answer it, but I'm fine if you just kind of do it that way. So here I said 3 non-collinear. You probably could have gone with more, less than that, but we'll probably say maybe what? I'll start you off and see if you can give me a last one. So A and B, do you agree those 2 are collinear, correct? Can you give me something then that if I put with A and B, all of a sudden becomes non-collinear? Yeah. D, right? Basically on that one, you could have given me any other point that was on here, right? And it was going to be non-collinear. A, B, because A and B is kind of shooting out this way and going back that way, right? So you could have given me any other point. Even C would have worked. Because C, if the line's up here, C's down below it, right? So they are non-collinear. I think for most people, the hardest part's the visualization of the 3D. It's probably the hardest part of getting the planar and non-coplanar and all that. Okay, any questions? There's another slide for no reason, apparently. Okay. Any questions on any of that?